Arigato. Ohayou gozaimasu. Thank you very much for inviting me and the whole NASA delegation here to the JPGU. And it's a real pleasure to be here to talk to you and with you about NASA and JAXA collaborations to advance science and to develop applications. Before I start, I would like to ask a few questions of the students in the audience. Who here is a student, high school or college?
高校生の方、中学生でもいいんですけど、学生の方、手を挙げていただけますか。
Okay, who of you would like to be a scientist or an engineer?
科学者や技術者になりたい方いらっしゃいますか。手を挙げていただけたらありがたいんですけど。
If you want to be a scientist or an engineer, who would like to work with JAXA or another space program to learn more about the Earth from space?
JAXA や他の研究機関で宇宙からこの地球のことを知るという研究課題やプログラムに関わりたいと思う方はいらっしゃいますか。
Only one or two. And who would like to spend your professional career learning more about the Earth on which we live and turning that knowledge into benefits for all of humanity?
Okay, so it's too long for me, but 宇宙から地球のことを知ってそれを利益に役立てるようなことをして、自分のキャリアを立てたいと思う人はどれぐらいいますかでいいですかね。ちょっと長くてすみません。
Nobody. Okay. Well, sorry. I'm giving you the wrong talk. No. What I will be talking to you today is in fact a mission called the Global Precipitation Measurement Mission, or GPM, which is a joint NASA, JAXA, or JAXA-NASA collaborative mission to measure rain over the entire globe, to use those measurements in association with other data to learn more about the Earth on which we live, and to then take that knowledge and develop applications which will make life better for all of us who live here. GPM is not the first mission that I personally have worked with JAXA, or before JAXA, NASDA on. In fact, all the way back in 1996, I was the principal investigator on the NSCAT instrument that flew on Adios or Midori 1. And in 2002, I was the principal investigator on the Seawinds instrument that flew on Midori 2 at that time. I have a long history of collaboration with JAXA and with Japanese scientists, and it has been very fruitful for my career. These instruments measured wind speed and direction over the world's oceans to understand how the wind drives the oceans and how there are ocean atmosphere exchanges of momentum and heat and chemicals and other quantities. But the GPM mission that I'm going to be talking about today with you is a mission to measure precipitation, rainfall, and snow over the entire globe. And water is extremely important for all of our lives, for everything that happens on Earth. Water is critical for life on Earth, for growing crops and food security. Water is also not so good sometimes when it rains on your vacation. And water, when it falls too much, can cause disruptions in society and flooding. Understanding the processes that control precipitation over the globe, and being able to predict precipitation accurately is important not only for understanding the Earth as an integrated system, but it's important for our everyday lives and our economies. And when we come to a situation, as the world is moving into right now, in which the weather extremes are growing more and more extremes. Heavy rainfall is becoming heavier in those regions of the earth. Droughts are becoming more intense in those regions of the earth. It is particularly important for us to understand the mechanisms that drive precipitation. You can see that just in the last few years, and just here in Japan and the Japanese region in Asia, there have been unseasonable extreme events such as snow in Tokyo this past February, such as more intense typhoons, precipitation leading to significant landslides and floods. So understanding the processes of precipitation are important to all of us, and that is why JAXA and NASA, along with other international partners, have collaborated in order to implement, to fly, and now to analyze measurements from the Global Precipitation Measurement Core Observatory. This is a satellite which is flying now, whose objective is indeed to give us new insights into the mechanisms and occurrences of rainfall, snowfall, and precipitation around the entire globe. The Core Observatory GPM has two basic instruments on it. The first is the JAXA-supplied instrument called the DPR, the Dual Frequency Precipitation Radar. It operates at two different microwave frequencies, at Ku band 13.6 gigahertz and at Ka band 35 gigahertz or so. This instrument is an improvement and a follow-on from the Japanese precipitation radar, which is flying now on the tropical rainfall measurement mission. That was a one-frequency radar, only Ku band. It flies in the tropics. It has been in space providing measurements to all of us since November of 1997. It is old. It is good. It can provide information on heavy rainfall in the tropics. But much of the rainfall around the globe is not in the tropics and is not heavy. And that's why the dual frequency precipitation radar on GPM includes the Ka band channels, which are more sensitive to light rain and perhaps even to ice and some snow. The dual frequency precipitation radar provides us with information not only about where it is raining and how hard it is raining, but also the vertical profiles of the rain characteristics. So as a function of altitude, with about 500-meter resolution, the DPR allows us to estimate drop size distributions and rainfall rates through the atmosphere. It does this in two relatively narrow swaths, about 125 kilometers for the Ka band and about 245 kilometers wide for the Ku band. The second, and you can see those swaths here, the second instrument on GPM is the so-called GMI, the GPM microwave imager. This instrument came from NASA, and it is an improved version of a microwave imager that is also flying on the tropical rainfall measurement mission TRIM. The GMI has a broad swath, almost 900 kilometers wide. It makes measurements of microwave emissions from the atmosphere and the Earth's surface at 13 different frequencies. Scientists can use that information and those measurements to estimate a whole variety of integrated quantities through the atmosphere. Not vertical, but integrated. So rain rates, humidity, atmospheric liquid water, etc. Together, GMI and the DPR provide us with unprecedented views of rainfall throughout the globe. And GMI and DPR and GPM as a mission do not operate alone. In fact, JAXA and NASA have designed this mission to work with a whole variety of other satellites that are flying right now, including TRIM, again from JAXA and NASA, but also satellites from Europe, weather satellites from the United States, satellites from India, and satellites from France. Together, all of these instruments and all of these missions provide information on precipitation, but with the GPM Core Observatory, which provides extremely high quality information, we can use that to cross-calibrate the other satellites and thereby use their information better thanks to the existence of GPM. So GPM is not only an important scientific mission, it not only builds on the JAXA-NASA tropical rainfall measurement mission, but it extends the range of our science to a whole variety of other satellite missions and international collaborations. I would now like to show you some animations that describe in more detail the launch of GPM and how it operates. So GPM indeed did launch from Tanegashima on the night of, or early morning of February 28th on an H-2A rocket. The president of JAXA was there. The U.S. Ambassador Carolyn Kennedy was at the launch site, and it was a wonderful launch, although very late at night. Soon after launch, the fairing was released, the solid boosters came off, and the first stage was jettisoned. And then the second stage with the GPM spacecraft continued into orbit, at which point the spacecraft itself was separated from the second stage. Making satellites and making them work is actually quite complicated. A few minutes after launch, the solar panels that provide energy to the satellite were released. The high-gain antenna, which communicates 24 hours a day, 7 days a week with the TDRS system, this is how we get the data back, was deployed. And then some days later, the GMI microwave imager was deployed. This is about a 1 meter, 1.2 meter dish, and it spins around about 14 times per minute or so. So this was the launch and the early operation of GPM. And that's the best part of the movie, by the way. Now, once on orbit, we got to get the credits. Once on orbit, GPM operates as we can see coming up. I talked to you about the dual frequency precipitation radar from JAXA, which makes vertical profiles of rain characteristics at two frequencies, the narrow swath and the broader swath from the Ka and the Ku band. And then the GMI from NASA, the microwave imager, makes integrated quantity measurements in 2 dimensions, not in 3, over nearly a 900-kilometer wide swath. And then there are all these other satellites which are also orbiting the Earth along with GPM, which you can see the core observatory of GPM in red here. And all of them are making measurements of precipitation quantities. And you can see that almost the entire globe is covered in only 3 hours by the combination of the high-quality measurements from GPM and the other measurements which are cross-calibrated with it from the other spacecraft. So GPM is truly a lever of knowledge and a lever of investment, because we can use the GPM measurements to get information that would not otherwise have been possible from the other missions, which are flying, many of them, for different reasons. But with GPM, we can calibrate their instruments with respect to rain and precipitation, and we can then combine those measurements from all of the spacecraft in order to get a global high accuracy for the first time measurements of precipitation. So in terms of GPM's science objectives, they're listed here. Basically, GPM provides a new reference standard for precipitation measurements from space. Never before have we been able to make measurements of precipitation, light rain, heavy rain, snow, and ice over as large an area with as great an accuracy as rapidly as we can with the JAXA-NASA GPM. We can use those measurements to improve our knowledge of the hydrologic cycle on Earth. That knowledge can be used for improved weather predictions and indeed for improved climate predictions. It's not enough, even though it's very difficult to predict the weather 5 days or 7 days from now. That's actually not enough. We as humans have the unique responsibility of being able to change what we do today based on our predictions of what the Earth's environment is going to be like generations into the future. So improving our knowledge of weather and meteorological phenomena today is important, but even as important or more important is understanding those processes so that we can predict in the future, under a changing environment, what the Earth will look like. And then using our knowledge of that, we can actually change what we are doing today to potentially take advantage of climate change or to mitigate the impacts of climate change. So the measurements from GPM, which are unique, can be used today, can be used for near-term predictions, and can be used for longer-term predictions. And since the water cycle is so important, since, as we saw before, GPM is precipitation is such an important feature of life on Earth, with impacts having to do with floods and landslides and drought, etc., the science measurements that our 2 agencies are making with GPM can actually be used and will be used and are being used to improve life on Earth through applications. So GPM is not simply a science mission, and it's not simply an applications mission. GPM is the combination of those. We make measurements, we understand the world better, we use that knowledge to make better predictions, and we use that knowledge to improve the quality of life. In all of these areas, in the areas of flood and landslide prediction, in the area of freshwater availability and food security, in the area of extreme weather events, and even in the area of world health, because it is well known that there are significant correlations between temperature and moisture and many vector-borne diseases around the world. GPM actually contributes to all of those, as shown here. Again, extreme events, landslides, floods, tropical cyclones, the insurance industry, freshwater availability and food security, weather and climate, and public health, and indeed ecology. So GPM is sort of the prime mission. It is international collaboration. It is at the cutting edge of science. It feeds directly into applications. It is precisely the sort of mission that you who are students ought to be thinking about into the future. GPM will be old news when you're making your contributions, but GPM proves that individuals in JAXA and NASA, in Japan, in the US, and indeed around the world can take their knowledge, can take their passion and drive to advance our understanding of the Earth and to make life better for everyone. Let me say a few words about the NASA program independent of GPM. GPM here is just one of many spacecraft and instruments that NASA is flying right now, making measurements of many different quantities all over the globe. The vantage point of space is key, is essential for us to understand the Earth as an integrated system, because individual processes, while complicated in and of themselves, are even more complicated when you consider that they are all linked together. It's not enough to understand one process in order to understand the Earth as an integrated system. We have to understand the linkages between processes. And not only are there linkages between processes, but there are also linkages between scales. What happens on small scales on the Earth is influenced by and influences what happens on large scales. So we need to be able to make measurements with high spatial resolution, but large spatial extent globally. We need to make measurements at a particular location frequently, but we have to make them for long periods of time everywhere. And we need to make measurements that have uniform accuracy and uniform sampling characteristics everywhere, independent of whether it's easy to make, easy to get to, or a difficult place to get to. The vantage point of space and putting instruments on satellites is therefore key to understanding the Earth as an integrated system. And NASA, along with JAXA and other space agencies, are flying Earth-observing satellites that are making measurements of many different quantities all over the globe. The missions here that are listed sort of in the bottom of this chart in sort of blue titles or yellow titles are missions that are flying and returning data right now, including GPM and including TRIM. And I will say also including QuickScat, which happens to be mine also, personally. The other missions, and so NASA is flying 17 missions right now, making measurements over the land, making measurements over the ocean, making measurements in the atmosphere, making measurements of chemical quantities, making measurements of thermodynamic processes, and making measurements of dynamics, and using all of those data to understand and to combine our knowledge of the Earth as an integrated system. And we have more than 10 more missions in NASA that are not only planned, but are funded for launch between July and the end of this decade. Not only are we flying all of these missions at the same time, but in fact, NASA and our international partners, including JAXA, have for several years now been flying some of the missions in close physical formation so that we can make a virtual observatory using instruments on lots and lots of different satellites that are making measurements almost simultaneously at the same place. The so-called A-train, which is composed of 6 or 7 satellites right now and a whole host of instruments, allows measurements at a particular location to be made from these different missions within a period of just a few minutes. And in fact, 2 of the spacecraft, CloudSat and Calypso, were flying only 17.5 seconds apart. Now they're flying 6.7 kilometers per second. So they were only 100 kilometers apart. And you can see in this picture taken by an amateur astronomer that he pointed his camera to the sky. This is the star Vega, and he caught the A-train coming over his camera. You can see the CloudSat track, and then you can see the Calypso track right here. They were both going sort of in this direction. And Calypso has a laser on board. Can anybody tell me what color the laser transmits in from Calypso? Well, you could probably say it in Japanese, but I'll say it in English. Green. You see the picture actually caught 2 shots of the Calypso laser, and it is indeed a green laser. And finally, in NASA, we are not only making measurements from free-flying satellites, but we are also using the International Space Station, including the Japanese Kibo module external facility, to make measurements of the Earth with Earth-observing instruments. We have several Earth-observing instruments on the space station right now, including a coastal zone hyperspectral imager, which is on the Kibo module right now. And in the next 2 years or so, we will be adding significant numbers of instruments, a lightning imaging sensor, a scatterometer, an instrument to measure vertical profiles in the stratosphere, and an instrument to measure clouds and aerosols, all from the space station. So we're using all of the assets that the space agencies have provided to learn more about the Earth. So for my final slide, let me just come back to GPM, okay? The Global Precipitation Mission. Only JAXA and NASA, the only 2 countries in the world, could actually conceive and execute GPM. Our collaborations have been strong for many, many years. And so we could get together not as 2 different space agencies, but as a collaborative partnership and conceive of a GPM that would be useful to the entire globe, that would leverage other satellites and other instruments as well. And the collaboration was absolutely essential. Neither of our agencies could have flown GPM alone. We couldn't have afforded it. We couldn't have technically done it. But together, we are leading the international space community. GPM, as I've said many times, integrates the observations from other satellite missions and other agencies. JAXA and NASA should and do feel very, very proud of leading the world in understanding the Earth as an integrated system through GPM. And GPM will indeed not only advance science, but it will enable applications and will improve life for everybody. Thanks very much for your attention, And thanks again for the invitation to address you here at JPGU. I hope the students will become strong scientists, good engineers, and great contributors to improving life on Earth into the future. Thanks very much.